Hey, welcome back, folks. We are talking about dynamics. We're into chapter 15, and we are looking at rotation. So in this example, we are given a rotating wheel that is accelerating at this rate here. So alpha equals alpha naught e to the negative t. We're given that alpha naught is 10 radians per second squared. The system starts from rest. It is a 600 millimeter wheel, the radius anyways, 600 millimeters, and they want us to find the total acceleration, so that is the normal and tangential, so a, not alpha but a, at t equals 0, at t equals 0.5, and at t equals infinity. So let's get to it. Let's see. Let's make a little line there. Keep us organized. And so we need A, which means that we're going to need the some equations. Let's just list them off. Okay, so let's say, what do we need? We need some equations. All right, so which ones? Well, let's see, they want A, so A is equal to, and we'll just draw it like this, right? A is equal to A n plus A t. Well, what is A n and A t? Well, let's see. A t is equal to, and I'm going to go ahead and just stop with the bars. You guys get the point, and it just clutters up the writing. So A equals an plus at. And then we'll just note that if we need to calculate it, then these are vectors, and we're going to need to use the Pythagorean to get the magnitude of it. So let's see. At, that is omega cross, wait, I'm sorry, that's not omega, that is alpha cross r, right? So the radial acceleration times that, and then a n, in this case, is omega, well, it's omega cross v, but in the 2D plane, this is actually just omega squared r. Which is, kind of nice. When you're working in a space that you can regard as two-dimensional, it's so much nicer because it's just multiplication instead of cross product. So let's see. We should note that V is equal to omega cross R. And what else? Oh, which alpha? Well, alpha here is a function of t, right? So we're going to need to derive that one, and let's see, we need this equation, right? We're going to need alpha equals d omega dt. Okay, so as we progress with this, it's a really good idea to see if you can do it by yourself. So now is a good place to pause the video and give it a shot. See if you can calculate the A for all of these, and see if you got it right. So, okay, well, I'm hoping that you pause the video. Let's get to this. So we need to, what I want to do is I want to find an equation that allows me to plug in the t and get the A, right? So I really want, what I want is the expanded version of this, and right now I'll settle for a sub n and a sub t, and in order to do that I need alpha, right? I'm going to need alpha, and I'm going to need omega. So let's see, alpha is equal to alpha naught times e to the minus t, and that is equal to d omega dt. Okay, this is 10, and so what I'm going to do is I am going to separate and integrate. So omega, and I would normally, let's say, here we go, there, we could go from omega naught, but omega naught is 0, so I'm just going to go from 0 to omega. That's going to be equal to 10 times e, well, let's see, we're integrating, so integrating from, and in this case, it's a good idea to go from, oh, this is t, so 0 to t. Sorry, for some reason I was thinking it was a. So 0 to t, and that is e to the minus t dt. Alright, so omega is equal to minus 10 e to the minus t. We're going from 0 to t. So that is equal to minus 10. And now this one, so e to the minus t minus e to the 0 is 1. And when I factor this in, it just reverses the order. So omega is equal to 10 times 1 minus e to the minus t. Okay, cool. Well, let's see. We are now interested in what, omega r, right? Let's see, hold on. We got to get to, we got the alpha. Okay, so let's see. We can actually do the cross r's, right? Why not? It's just times r. So where are we at? We're at 0.6. So we've got omega. Let's finish that out first. We'll say omega cross r. In this case is equal to omega r. And for us that is 0.6 times this. So that is 6. Hold on. No, we're going to need to square it. Right? So a sub n is omega squared r. So let's do this. Say omega cross this is actually just omega squared r. And what is that? That is 100 times 1 minus e to the minus t squared times 0.6. Okay, so omega squared r is 60, 1 minus e to the minus t squared. Okay, all right. Alpha, well, we need that. Underline that. So alpha cross r, because we're in a plane, is alpha r. So that is, I'll just say alpha r. Well, wait, alpha r has a name, right? That is a sub t. So a sub t is equal to 0.6 times 10, sorry, times 10 is 6. 6 e to the minus t. This, that is a sub n. Okay, all right, so now we have equations. And for each of these, we need to consider it. Okay, so these are our equations. All right, so for a, t equals 0. T equals 0, so that means that e to the minus t equals 1. So let's see, a sub n equals 60. 1 minus e to the 0 is 1 squared. That goes to 0. Okay, and a sub t is 6 times 1 is 6. We'll say 1, so then A equals 6. And what is that? That is meters per second squared. Okay, all right, B. So for B, T equals 0.5. Okay, and so A sub n equals 60 times 1 minus e to the minus 0.5 squared. Going to need to run that one through my calculator. Let's see. 60 times 1 minus e to the minus 0.5 squared. Okay, and that is, let me go ahead and bring it down. I may need room over there. So A sub n is equal to 9.289. Okay, A sub t is 6 e to the minus 0.5. That is 3.639. Okay, and we need to do the Pythagorean, so A is 9.289 squared plus 3.639 squared. Alright, so A is, drum roll please, 9.289 squared plus 3.639 squared. That gives me 9.976. And that, again, meters per second squared. Okay. So, let's see. Okay, and part C, t equals infinity. So, don't let this trip you up. Here's what it means. So, e to the minus t is a decaying exponential. And as we noticed, so if we just map this, if we just plot it out, e to the 0 was 1, right? So 1 goes here. This is y-axis, x-axis. So we're 0 here. Wow, I really just did that, didn't I? So y-axis, x-axis, this is 0. And it's shaped like this, right? And the general idea is that when you get to infinity, that's the only time that e to the minus c gets to 0. So wherever you see e to the minus t at t equals infinity, it goes to 0. You can do the limit, you can take the limit if you want, but you're going to get to 0. So what do we want? We want a sub n. A sub n is 60 times 1 minus, and now it's going to be 0, right, squared, which means nothing. So a sub n equals 60. Okay, a sub t equals 6 times, where are we at? Here, e to the negative infinity is 0, so this is 0. So a equals 60 meters per second squared. There we go. Okay, well, there you have it. Not too tough, and this is more along the lines of how we're going to be using this rotation stuff, at least for this problem. So I hope that was helpful. Good luck on the associated homework problems, and I will see you in the next video.